Hello again. So this is the continuation of solving problems in Kirchhoff's law. Okay, this time we're going to use the branch current method. Okay, so for a while. Okay, again, we're given the same problem, 18 volts and 24 volts power source. Then we have two resistors. R1 is 3 ohms, R2 is 3 ohms, and R3 is 6 ohms. Okay, so same process. First, we're going to determine the charges. Okay, it's positive or negative charge. So the battery here is positive, here is negative. Then resistor going this direction, negative to positive. It is negative, positive, and then going down, negative, positive. So going back, it's still positive. Okay, in this case, in this direction, negative to positive. So this is positive, negative, negative, positive, and down is negative, positive. Okay, so now we're going to be solving for the unknowns, which are, we have I1 and E1, I2 and E2, and then I3 and E3. Okay, so first we determine the direction of the currents. Okay, so in this point we have a node here or a junction. So your I1 is going in this direction, while your I2 is going in this direction, and I3 is going down. Okay, so again, using Kirchhoff's current law, where it states that any current entering a node or a junction is positive, while current leaving a node or junction is negative. Okay, so in this case, I1 and I2 are entering a node, so they are positive. So I1 and I2 are positive, while I3 here is leaving the node, so it is negative. So minus I3. Okay, so arranging the equation lang. So this should be equal to 0. Okay, so it states that currents entering a node is positive, are positive. In this case, they are 2. And then a current leaving a node is negative. So as you can see in the figure, if we're going this direction, so I1 is entering a node and I2 is also entering the same node or junction. So they are positive. And I3 is leaving the junction or the node. So it is negative. So arranging it to be a proper equation, it is I1 plus I2 is equal to I3. Okay, so that will be our first equation for current. Okay, now we're going to discuss the loops. Okay, so in a closed loop, the voltages should be equal to 0. Okay, so when the summation or algebraic sum of the voltages should be equal to 0. So that is this loop negative to positive. So this is your loop 1 and this is your loop 2. Okay, now for loop 1, for loop number 1, so here, okay, this is where we're going to use the charges, okay, positive and negative. So here it hits positive 18. So 18 here is positive. Okay, I'll be writing the unit of volts, the final answer na lang, since we're talking about voltages. So pare-pare lang na volts yan, okay? So it's here, it's positive. Then goes up there, it's negative. So it is minus E1, voltage in 1 is negative. Then going down again, it hits negative. So your E3 is negative. So minus E3, that is equal to 0. Okay, so that's your first loop. In loop 2, okay, the second loop, so here it hits positive, so 24 volts is positive. Okay, going up, negative, so R2, so E2 here is negative, minus E2, and then going down again, it hits negative R3, so the voltage is negative. So it is negative E3 is equal to 0. Okay, now I'm just going to transform the equation to look like a proper equation using the constant or putting the constant right side of the equation. Okay, so pag nag-transpose tayo, this becomes negative. So pag nag-cancel tayo negative sign, this 2 becomes positive na. So it is E1 plus E3 is equal to 18. And then here, lipat natin doon, this becomes negative. Then when you transform it to positive, multiply both sides by negative 1, this 2 becomes positive. So it is E2 plus E3 is equal to 24. Or to make it easier, parang itong dalawang ito, na negative siya, transpose mo lang doon. So they became positive. And this 2 transpose mo doon, so both negative, they became positive. Okay, so the problem naman here, okay, is you have 2 equations, but you have 3 unknowns. So you're looking for E1, E3, and E2. So tatlo. Sa current, then we have I1, I2, and I3. So tatlo sila. But we have only 2 equations. Okay? So dapat equate natin sila na maging isa lang. Okay? Now, if we're going to look for the values of this. Mayroon ka lang kasing given na R. Okay? So yung E mo, alam natin, your voltage is equal to your current multiplied by your resistance. Okay? So meaning, pag pinunta natin itong mga values na to, this becomes E1 is equal to I1 multiplied by R1 plus I3 multiplied by R3 is equal to 18. Okay? In this case naman, here it is I2 multiplied by R2 plus I3 multiplied by R3 is equal to 24. So this is clear, no? So since E1 is equal to I1 times R1. So palitan natin sila. Okay? Now, lagay natin yung values ng R. So your R1 is 3, R2 is 3, and R3 is 6. So R1 mo here is 3 multiplied by I1 plus your I3, ang R3 mo is 6. 6 multiplied by R3. So I just changed the values of R's, no, from the given. Okay, so your R1 is 3 multiplied by I1, then your R3 is 6 multiplied by I3 is equal to 18. Okay, here it is R2 left, which is 3 ohms multiplied by I2 plus your R3 again is 6 ohms multiplied by I3 is equal to 24. Okay, so still we have 3 unknowns with only 2 equations. So we have I1, I3, and I2 are missing, 3 of them, but we have only 2 equations na pwede natin gamitin. So what we're going to do is going to cancel or going to substitute one value so that there will only be 2 unknowns. Okay, so pwede mo lang palitan is this one. Okay, so we know that I3 is equal to I1 plus I2. So we substitute the value of I3 to I1 plus I2. So here we get 3 I1 plus 6. Okay, multiplied by your I3 will be changed, or we're going to substitute I3 to I1 plus I2. So that is I1 plus I2 is equal to 18. And here it is 3 I2 plus 6 multiplied by I1 plus I2 is equal to 24. Hopefully you could still there is equal to 24. Okay, now we distribute. Okay, yung 6. Okay, so it is now, I'll be moving here para makita niyo yung dulo. Okay, so it is 3 I1 plus 6 I1 plus 6 I2 is equal to 24, sorry, 18. Okay, so there. And then here, distribute natin yung 6 sa dalawa. It is 3 I2 plus 6 I1 plus 6 I2 is equal to 24. Okay, so hopefully you can see pa yung baba. I'll be adding lang yung mga pareho. So I1 and I1, so it is 3 I1 and 6 I1. Okay, I'll write it here na lang, okay, para magkasya siya. Okay, it is 9. So it is 9 I1 plus 6 I2 is equal to 18. Okay. And the other one, so this is your first equation, this is from loop 1, okay? This is from loop 1. Loop 1, sorry, loop 1. Okay, so that's 18. And then from loop 2, we have 6I1. Then plus we have 3I2 and 6I2. So we have 9I2 is equal to 24. Okay, now in lowest term natin sila. Okay, so baba ko muna to. Baba ko to para ma-lowest term natin yan. So it is 6I1 plus 9I2 is equal to 24. So I think we could cancel out a factor para maging bumaba siya ng value. Okay, so 3 is common. We cancel 3. So we have 3I1 plus 2I2 is equal to 6. Okay, so that's the equation from loop 1. And here we could still cancel 3. Okay, so we have 2I2 plus 3I2, sorry, 2I1, sorry, plus 3I2 is equal to 8. Okay, so to get the values, we're going to use substitution or cancellation. So I think we should use cancellation na lang gamitin natin. So I'll be using a different board. I think hindi na kasya doon. Okay, parang hindi na aabot. Okay, I think I'll do it this way. Okay, para medyo mataas siya. Okay. So I'll be writing here, this is your first equation, 3I1 plus 2I2 is equal to 6. And then your second is equal to 2I1 plus 3I2 is equal to 8. Okay, so ito yung equations natin, equation 1, equation 2. So, pwede tayo familiar kung sa ating cancel, no? So, we could cancel 1, I1. So, this is 3I1 and 2I1. So, para magpareho sila, magawin natin silang 6. Okay, so we multiply 2 here and 3 here. Okay, so we distribute, we get 6I1 plus 4I2, then here, okay, is equal to 12. Okay, now next is this one, we distribute 3, so we get 6I1 plus 9I2 is equal to 3 times 8 is 24. Okay, so we subtract, so pwede na makancel to, that's equal to 0. So 4 minus 9 is negative 5I2, okay, and then equal to, it is 12 minus 24, that's negative 12. Okay, so your I2 now is equal to negative 12 divided by negative 5. So I2 now is equal to, so let's see, to be sure, I'll use the calculator. Okay, it's actually 2.4, but para sigurado. Okay, so it's 12 divided by 5. Okay, yeah, I'm right. It's 2.4 amperes. Okay, so since may I2 ka na, you could use this value substituted in any of these equations. So pwede mong piliin ito, o pwede mong piliin ito. You'll get the same answer. Okay, so I'll be using yung 1. Okay, so ito yung equation 1 natin. No? So this is from 1. No, I think it's substitute. Mas maganda ganun. Substitute in equation 1. Okay, so I2 mo is 2.4, therefore it is 3I1 plus 2 multiplied by 2.4 is equal to 6. Okay, so this is 3I1 plus 4.8 is equal to 6. Okay, so 3I1, dito na lang. 3I1 is equal to 6 minus 4.8. Okay, so therefore, oops, that is equal to I1 is equal to, this is 1.2. Okay, 1.2 divided by 3. So I1 is equal to, I think it's 0.4, just to be sure. 1.2 divided by 3. Okay, it's 0.4. So 0.4 ampere. So that is your I1. Okay, so we have your I2 and we have your here, I1. Okay, now for I3, we know that I3 is equal to I1 plus I2, okay, from the first equation. Therefore, I3 mo is just equal to 0.4 plus 2.4. So your, hopefully you can still see it, okay? I'll just raise it up a bit. Yan siya. Okay, so your I3 now is equal to 2.8 amperes. Yeah. So here's the solution. Hopefully you can see it na, okay? So there, your I2 is 2.4 and your I1 is 0.4. So I3 is I1 plus I2, therefore it is 0.4 plus 2.4. That is equal to 2.8 amperes. Now let us write the values here at our problem. Okay. So your I1, let's remove the loop first. Okay. Your I1 now is 0. Sorry. 0.4. Okay, 0.4 amperes. Your I2 is 2.4 amperes. Your I3 is equal to 2.8 amperes. Okay. Now let us multiply R and E to get the voltages. Okay. So for E1 it is 0.4 multiplied by 3. That is 1.2 volts. Okay. E2 now is 2.4 multiplied by 3, that is equal to 7.2. 7.2 volts, okay? And finally, 2.8 multiplied by 6. So that's equal to 16.8 volts. Okay, so let's try to check. Okay, so here, dapat 0 siya. So we're going to use this to check yung loop. Okay, so it is 18 now, that is 18, okay? 18 minus E1, which is 1.2, minus 1.2. Then minus again your E3, which is equal to 16.8. So minus 16.8. Okay, so that is equal to 0. So this one is correct in the first loop. Second loop is 24 minus E2, which is 7.2, minus your E3, which is 16.8. 16.8. Okay, so it's equal to 0. So tama siya. So we satisfied the law, the Kirchhoff's laws. Okay, so first is yung current law, which is correct since it is 0.4 plus 2.4, that is 2.8. Okay, so it is satisfied sa nakuha to. And then finally, in a closed circuit, okay, so the voltages algebraic sum should be equal to 0. So pag sinamit natin yung mga values na to, with this one, we get 0 and we get 0. Okay, so that's it. So hopefully you understood the solution. This is still Kirchhoff's law. We use the branch current method in solving for the unknown. This is just for 3 resistors and 2 batteries. Okay, so I think that's all. And kindly, if you're confused now or para nalito kayo sa pagkasal, you could watch the video again. Okay, to show you or for you to analyze better. Okay, kung saan ba nakuha yung mga values. Okay, so I think that's all. And see you again on the next video. Okay, good day to everyone.